Welcome to ScienceCover.com. This session is on stopping distance. The aims of the session are to look at stopping distances, thinking distances, and braking distances. To know the factors that affect the thinking distance and the braking distance, and to show the information on a graph. Before we begin, pause the video and attempt the Do Now task. Let's check our answers. Question 1. Calculate the weight of a 10 kilogram barrel of oil. So weight is equal to mass times gravitational field, which is 10 times 9.8, that's 980 newtons. Calculate the mass of a bear if the bear has a weight of 2,940 newtons. So mass is weight divided by gravity. So that's 2,940 divided by 9.8, which is equal to 300 kilograms. On Venus, a 70 kilogram astronaut has a weight of 620.9 newtons. What is the strength of the gravitational field on Venus? So the gravitational field strength is equal to the weight divided by the mass. So that's 620.9 divided by 70, which is equal to 8.87 meters per second squared. How does this compare with the field on the Earth? It's slightly weaker than the Earth's gravitational pull. What is terminal velocity? This is when an object is in free fall and it has a drag force equal in size to its weight. There is no net force, so there is no acceleration, and the object will fall at a constant speed. Now let's look at stopping distance. For a moving vehicle, the stopping distance is made up of two factors. The thinking distance is the distance that the vehicle travels in the time taken for the driver to react. And the braking distance, which is the distance that the vehicle travels between when the brake is applied and when the car comes to a stop. So the total stopping distance is equal to the thinking distance added to the braking distance. To show how this works, imagine that we have a cyclist and that a child runs out in front of this cyclist. It will take time for the driver to see the child, process what they have seen, and react by moving their foot to the brake. The distance that the bike travels during this time is known as the thinking distance. Once the cyclist applies the brake, the bike will not instantly stop, it will slow down over a distance. Now this is known as the braking distance. So the thinking distance and the braking distance together are known as the stopping distance. Pause the video now and complete task 1. Let's check our answers. What is the stopping distance? Stopping distance is the thinking distance plus the braking distance. What is the thinking distance? This is the distance travelled by the vehicle during the time it takes for the driver to react. What is the braking distance? This is the distance travelled by the vehicle between when the driver pushes the brake and when the car comes to a stop. On the diagram, label the stopping distance, thinking distance, and braking distance. So the thinking distance is on the left-hand side, the braking distance will be on the right-hand side, and the stopping distance is both the thinking distance and the braking distance together. Now let's look at the factors that affect thinking distance. Thinking distance is the distance travelled in the time taken for the driver to react. This means that a driver's reaction time has a direct effect on the thinking distance. Any factors that will influence will affect their thinking distance. Some of the factors that may influence thinking distance are the age of the driver, whether they have consumed alcohol, the use of drugs. This includes legal drugs or drugs taken for medical use. Tiredness. Any form of distraction, such as a phone or music or using a navigation device while driving. Or any particular medical issue or feeling unwell. In order to react to any danger, a driver must first of all see the danger. This signal gets sent from the eye to the brain. They then process what they have seen, and then a signal gets sent from the brain to the muscles, telling the muscles to react. All of this process takes time, and any of the factors that we've mentioned, such as distractions or drug or alcohol use, slow down that process. To try to protect the public, a series of laws have been created that drivers must adhere to. It is now illegal to drink alcohol and drive, to take drugs and drive. This includes many types of legal drugs and drugs used for medical uses. To use your phone while driving, as it's a distraction. To program any device, such as a sat-nav, while driving. Or to drive a car when you are unfit to do so. Pause the video now and complete task 2. Let's check our answers. List 5 factors that affect the thinking distance. You could have selected alcohol consumption, drug use, tiredness, age, medical issues, or any form of distraction, such as music, a sat-nav, or a phone. Question 2. Name 2 laws that have been created to help ensure drivers keep their thinking time at a reasonable level. No drinking alcohol and driving. No driving after taking drowsy medication. No drug use and driving. No using your phone while driving. No changing the sat-nav whilst driving. Let's now look at the factors that affect the braking distance. The braking distance is the distance that a vehicle travels between when the brake is applied and when the vehicle comes to a stop. This can be affected by the mass of the vehicle. A vehicle with a large mass will have a larger braking distance than a vehicle with a smaller mass. Another factor that affects braking distance is the speed of the vehicle. Vehicles that are travelling faster require a larger braking distance. The condition of the tyres or brake pads will also affect the braking distance. We can class this as vehicle maintenance. The weather conditions, such as whether it's snow, ice, or rain on the road, can also affect the braking distance. And the surface of the road itself, whether it's tarmac or loose stone, sand or mud, will also affect the braking distance. Pause the video now and complete task 3. Let's check your answers to task 3. What factors affect the braking distance? We have the mass of the vehicle, the speed of the vehicle maintenance, such as the condition of the tyres, the brake pads, the weather conditions, whether it's snow, ice or rain, the surface of the road, whether it's tarmac or loose stones, sand or mud. Use the graph below to complete the table. So at a speed of 20, the braking distance is 6. At a speed of 30, it's 14. At a speed of 40, it's 24. At a speed of 50, it's 38. At a speed of 60, it's 55. And at a speed of 70, it's 75. Why is the speed limit on a motorway 70 miles per hour for a car, but 60 miles per hour for a lorry or a truck? This is because the lorry or truck has got a higher mass than the car. Because it has a higher mass, it has a longer braking distance. Now let's look at how we'd represent stopping distance on a graph. This table shows the thinking distance and the braking distance for a car travelling at different speeds. To calculate the stopping distance, we must add together the thinking distance and the braking distance. So at 20 miles an hour, the stopping distance is 6 meters plus 6 meters, which equals 12 meters. At 30 miles per hour, the stopping distance is 9 meters plus 14 meters. This is 23 meters. We can carry on this process until we have a value for stopping distance for each of the speeds. We can plot this data on a graph. Here we see the speed on the x-axis and the stopping distance on the y-axis. The data shows a curved line. As the speed increases, the stopping distance increases. However, the gradient of the graph changes. This means that any change in speed at a high speed will produce a larger change in stopping distance than it would have at a lower speed. Pause the video now and complete task 4. Let's check our answers to task 4. The stopping distances should have been 12 meters, 23 meters, 36 meters, 53 meters, 73 meters, and 96 meters. The plot of the graph and the line of best fit are shown on the screen now.